All right, welcome to Success Math 120 class. The topic in focus today is differentiation. The topic in focus today is differentiation. And class, first and foremost, I'd like to teach us how to differentiate a normal function like 3x raised to power 5. We want to start with basic differentiation. That's simple differentiation. That means when you have an expression that has a coefficient, a base, and a power, this is the first thing you should know how to do when you want to differentiate. Class, if you have 3x raised to power 5, 3 is called the coefficient, x is called the base, 5 is called the power. Class, when you want to differentiate, you must first recognize your coefficient, base, and power. When you want to differentiate, you must first recognize your coefficient, base, and power. Class, your coefficient is the number before x. It's called the coefficient. X is called the base, and 5 is called the... You must recognize your coefficient, base, and power. Class, if you have another expression like y equals to 4x raised to power 2, 4 is the coefficient, x is the base, 2 is the... So this is how you recognize your coefficient, base, and power. Coefficient is the number that comes before the x. X is the base, and the power is the one on top of the x. Class, when differentiating, first and foremost, you must multiply coefficient and power. Step 1 is to multiply coefficient and... Class, this one is basic differentiation. That's simple differentiation. Let's call it basic derivative. Class, another name for differentiation is derivative. Basic derivative rule. Step 1, multiply coefficient and power. Step 2, repeat the base, repeat what? Base. And step 3, subtract 1 from the power. Class, these are the 3 simple steps for basic simple differentiation. These are the 3 simple steps for basic simple what? Differentiation. 1, multiply coefficient and power. 2, repeat the base. 3, subtract 1 from the power. Now, class, looking at this, y equals to 3x raised to power 5. Let's apply the 3 rules. Step 1 said we should, and class, when you want to differentiate, you say dy dx. Because class, the expression of differentiation is to find the change in y with respect to the change in x. That is the ratio of the change in y to that of change in what? Is called different. That's dy means change in y, dx means change in. So the ratio of the change in y, dy, to the ratio of the change in x, dx, is called differential dy. And dy dx, this first step say multiply the coefficient and the... That's 3 times 5, 15. 3 times 5. Step 2 say repeat the base. Who is the base? X. So write down your x. I've written my x. And step 3 say remove 1 or subtract 1 from the... So 5 minus 1. So class, the differentiation of 3x raised to power 5 is 15x raised to power 4. The differentiation of 3x raised to power 5 is 15x raised to power 4. Class, let's do the same thing for this second one. Y equals to 4x raised to power 2. We want to differentiate. The y dx. We say coefficient times power. 4 times 2. 8. Repeat your base. X. Subtract 1 from the power. 2 minus 1. So we end up having 8x raised to power 1. 8x raised to power 1. So the differentiation of 4x squared is 8x raised to power 1. The differentiation of 4x raised to power 2 is 8x raised to power 1. Some people will not sit up until they see their first F. Some people will not sit up until it's normal class. If everybody is serious, how will we get F every year? We need F for the school to survive. F is very, very, it's important. It's important for some people to get. So some people will not sit up until they see their first F. They rather go home after lecture. If lecture ended today by 6, some people will still be in school by 6. But lecture ended by 1, they went home. But now they remember that they are tired. But if there was lecture till 6, I don't know days we used to have lecture till 6. They stay till 6 because it's lecture. That they will not understand anything. No? But because they called it because they called it what? They will sit down and waste their time. They don't know anything. They can't even write their assignment by themselves. When they say, just give us a 1-hour class, 2-hour class to explain to you what they're teaching in the lecture. I'm tired, I'm staying far. But there are days the lecture ends by 6. Some people still stay till that 6 because of the fear of lecture. Even if they don't understand any. Some people have been attending lecture for 4 or 5 weeks now. They don't know anything in this Math 120. Does that not tell you that your lecture is not effective enough? Some people think that you are immune to F, that you are special. You're nobody special. Class, F is not a respecter of anybody, no matter where you came from. Whether you're a Christian, you're a Muslim. Any score less than 40 class, you are on F. The school doesn't follow. Nobody knows you. Any score less than 40 is what? It's very easy to get F. Because why I don't bother too much is that if you don't learn now, every new set, we have a carryover group. Don't worry, I'll post the current attendance in my carryover group on our one, so you can see how many people are in carryover. And that one, nobody is to beg you. I just post it once, my status. People will be joining. I just post it once, the link, once, my status. You failed any course, I don't beg them. You see people that you were begging to come to class before, now, they are not the one rushing. I have a Sunday class. This Sunday, I have a class for carryover students on Sunday. You see the attendance. If you are staying around, so come here by 3 p.m. on Sunday because they don't have time during the week. So it's only Sunday they are free. How can you put yourself through that stress? It means that year 2 now, if you fail any course, you don't even have any free day. Because you're adding year 1 stress to your year 2 stress. If you fail any course, you're adding your year 1 stress to your what? Double stress on your head. I can't come to school on Saturday. I can't come to school on Saturday. When they fail now, Sunday they are coming. Not even Saturday, Sunday. They say, so I said I don't have time. I'm teaching Jam, I'm teaching year 1. I have a driving school. I have students that teach my driving school. I don't have time. They say, so let's meet on Sunday. They will come. They are the one that fix Sunday. It's not me. People that say Saturday, they cannot come. Some of you have not entered school on Saturday before. You use it and rest, right? Don't allow F to rest on your head. If lecture fixed test on Saturday, you would have come to school. But because they say, this one, they cannot do anything, I will stay at home. Class, pass through the stress and pass it once now. Go through all the stress. Don't say I'm tired on Saturday. Go through all the stress and pass it. Tomorrow we have class Saturday. Some of you have stopped coming for Saturday class. Better sit up back. If you fail any course, that test you buy it again. For this manual, you have already filled it this year. So if you fail this course now, you have to buy the manual again. You cannot use the same manual. You have already filled it, right? You have to answer the manual again. Now you cannot do math without filling this. Meaning you are buying the manual and you have your year 2 textbooks to buy. You will not buy year 1 with it. You better sit up. If the first class come, now that you're in year 1, there's no shame in doing year 1 course. If in year 2 now, you'll not be hiding. You know how many year 2 students says I cannot come for your normal class. I failed math. How will you do it for us? I cannot come. Shame, don't catch them now. But they were begging them in 100 level to come for that same class. They were begging them in 100 level to come for that same. This is the level you can do the course. Pass it. You are in that level. This is the time to pass the course. This is the time for this. When it gets to 200 level, you are still doing this course. It can now become shame. It's no more your time. Your time has passed, but you are still doing the course. This is the time to pass the course now. A word is enough for the wise. Please sit up. Please say it up. Please say it up. Now, let's go to first principle. So I've taught you basic differentiation. But class, okay, one more thing. If they give you a function y equals to 4x raised to power 7. And you have to find the third derivative. The third what? Find the third derivative of the function y equals to 4x raised to power 7. Find the third derivative of y equals to 4x raised to power. Class, it means you will differentiate this function 3 times. Differentiate the function how many times? 3 times. So the first derivative is y prime. Second derivative is y prime prime. Third derivative is y prime prime prime. Let's differentiate the first time. What do we have? 4 times 7. 28x raised to power 6, subtract 1 from the power, right? Second derivative, 28 times 6, someone should help me. 168 x, 6 minus 1. Third derivative, 168 times 5. 840 x raised to power what? Notice that the power is reducing by 1 as you're coming down. The power is reducing by 1 as you are coming. Some people who did online class, they now stop coming for physical class. Something that's supposed to help you in the days you miss class. You now use it to replace class completely. I might still stop that. And if people are not serious, I will stop it. Class, third derivative, 840x raised to power 4. This is how you find third. So class, let me give you a class for differentiate y. Even this simple basic differentiation, tough question can come out. Differentiate y equals to 2 root x. Class work, differentiate y equals to 2 root. How will you go about it? So don't forget, I want to clean this side now. If you want to differentiate, first derivative means differentiate once. Second derivative means differentiate twice. Third derivative means differentiate 3 times. Class, are we together? Class work. Differentiate y equals to 2 root x. Yes. You see, in my example, I've not mentioned square root, but class work can give in square root, right? That's what teachers do. They take simple examples, then give tough class work. Differentiate y equals to 2 root x, class. What will you do? Follow me. That will be y equals to 2 root x is 2x raised to power 1 over 2, class. The square root of any variable is that variable raised to power 1 over. The square root of any variable is that variable raised to power 1 over 2. So 2 root x means 2x raised to power 1 over 2, class. 2 root x means 2x raised to power 1 over 2. Because class, the square root of x is x raised to power 1 over 2. Had it been this question said y equals to 2 cube root x, it will be y equals to 2x raised to power 1 over. Class, the cube root of any function is that function raised to power 1 over 3. The cube root of any function is that function raised to power what? And the square root of any function is that function raised to power 1 over 2. Class, are we following? Class, all of a sudden from square root to x raised to power 1 over 2, it looks more easy to differentiate now. Because at this level, we know our coefficient, we know our base, and we know our power. At this point, our coefficient, base, and power is clear. Is what? When it was 2 root x, it was not clear. It doesn't look as if it had any power. But remember, I always remember, anytime they give you a square root function, it has to differentiate. Change that square root to x raised to power 1 over. And if they give you cube root, x raised to power 1 over. If they give you fourth root, x raised to power 1 over 4. What if they give you y equals to square root of x all cube? Differentiates. Y equals to square root of x all cube different. Class, this is a law in indices called the fractional index law. The fractional index law tells us that the power and the roots, the power represents the numerator, the root represents the denominator. Class, this can be changed to y equals to x raised to power 3 all over. Class, x raised to power 3 over 2 is the same thing as the square root of x cubed. Who remembers this rule in indices? Secondary school, remember this rule? That square root of x raised to power 3 is x raised to power 3 over 2. Class, is this at this point, it looks difficult to differentiate. But when you bring it in this form, it's easier to differentiate. These are ways they can twist a question for you in the exam. These are ways they can twist the question for you in the what? And make it more difficult. Class, if you are online and you are in your WhatsApp group, can you help us inform your colleagues that Math 120 class is ongoing? They should come to PSO. I initially posted new lecture, right? I saw some of you are coming from new lecture, right? But we changed the all. I noticed that this all is free and we have our board here. It's easier. So it's more comfortable here. So let us use this venue. So we changed the venue. It's possible that some students might be looking for us. Please, if you're online and you have data, please help us. It won't take you much time, please. Inform your colleagues that they should come from Math 120 class. We are at PS, or please do that, please. If you're online, please. Just inform your colleagues on the WhatsApp group, departmental group, that they should come to PS or Math 120 class is ongoing. Come to PS or Math 120 class is ongoing. Class. So let us solve from this. I will differentiate everybody here. Let us start with 2 root x is 2x raised to power 1 over 2. Please do it. Don't forget, do it. Come to PS or Math 120 class ongoing. Come to PS or Math 120 class ongoing. Now, these are coefficient, these are base, these are power. So multiply coefficient and power. 2 times 1 over 2 is 1. Do you agree? 2 times 1 over 2 means 2 cancels 2. What's left? So multiply coefficient and power. 2 times 1 over 2 is 1. Repeat your base, step 2, right? Remember there are 3 steps. I'm following the 3 steps now. And step 3, subtract 1 from the power. 1 over 2 minus 1 is minus 1 over 2. Confirm. 1 over 2 minus 1 is minus 1 over... 1 over 2 minus 1 is what? So, division of 2x raised to power 1 over 2, which was obtained from 2 root x, is 1x raised to power minus 1 over 2, which can be written as class. This minus can disappear if this x raised to power 1 over 2 comes down. It will now be 1 all over x raised to power 1 over 2. Class, no more minus. When this x raised to power 1 over 2 was up, it had a minus sign, right? When it comes down, the minus disappear. We are allowed to clean the... It's a mathematical rule. It's a mathematical what? That when someone is having a power, a negative power, when it comes down to the denominator part, the power will disappear. But if it goes up back, the minus will come back. It's a rule in mathematics class. So 1x raised to power minus 1 over 2 can now be 1 all over x raised to power 1 over 2 without the minus, which is now the same thing as class. We can now return x raised to 1 over 2 back to its form of root. Do you agree that x raised to 1 over 2 is still same thing as root x? Because I told you that square root of any variable is that variable raised to power 1 over. So I can change x raised to 1 over 2 back to root x, or I can change root x back to x raised to power 1 over, depending on when I need it and what part do I need. Since I'm done differentiating, I can return this x raised to 1 over 2 back to root x. So my final answer is 1 over root. But let me surprise you. If the lecturer wants to be wicked, class, we don't like our denominator to be in sod. I can rationalize this sod. This is what we call rationalization of what? How do I rationalize? You may not see this in the option. See one wicked thing about your exam at 120. After suffering to differentiate, you now got the answer. Lecturer has now transformed the answer to another shape. Class, 1 over root x is correct, but this is wrong sodically. In sod form, this is what? If you have studied sod, you know that it's wrong for a denominator to have sod, right? So we call rationalization of sod. We did it in math 110, remember? Rationalization of, how do you rationalize a sod? Imagine after suffering to get here, you didn't see this in the option, you think you are wrong. You know, so people will go back to differentiate. But someone that is good in math will say, oh, is it possible they have rationalized it? 1 over root x, you multiply both numerator and denominator by root. 1 times root x is root. Root x times root x is what? So final answer is root x over x. If they didn't tell you, you will never know. If they don't tell you, you will never. You keep looking for 1 over root x, you will never see it. Lecturer has rationalized this to. The lecturer has rationalized 1 over root x to what? This is why this course is the most failed course. In my carryover group, we have over 200 students there. I asked them a simple question. Which course? I did a poll. Which course did you fail the most? I put Chem 130. I put Math 120. I put Physics. Guess. This is where they fail more. Many of them. F. This guy finished many people. Because you can know how to differentiate and your answer will not be in the option. They have changed it to another form. They have rationalized your answer. They have factorized your answer. Yes, my friend. Sorry, your voice is low. It is 1 over 2 minus 1. That's how we subtract 1 from the power. 1 over 2 minus 1 is minus 1 over. Class, in case I was too fast, can I just slowly come again? I'll slowly come again. Let me slowly come again. This is a tough course. This is a tough. It needs patience. It needs patience. Let me slowly come. Teach you step by step. Class. I'll take you back to the question. The question said y, differentiate y equals to 2 root x. Class, 2 root x will be difficult to differentiate until you change root x to what? X raised to power 1 over 2. Because the square root of any variable, the square root of y is y raised to power 1 over 2. The square root of z is z raised to power 1 over 2. The square root of any variable is that variable raised to power 1 over 2. So the square root of x is x raised to power 1 over 2. But of course, there was a 2 before the square root, right? So you bring the 2. 2x raised to power 1 over. Class, this square root turning to x raised to power 1 over 2 does not affect this 2 behind. Though. It's still there. You see the 2 here. But we change this square root of x to x raised to power 1 over. Class, why did we change it? Because in this form, we can easily see our coefficient, our base, and our power. In this form, our coefficient, base, and power is not clear, right? Because there's no clear power here, it's a square root. So I change the square root to x raised to power 1 over. Class, are we following? Now, we'll now apply the 3 basic rules of different, which I taught you. Step 1 says multiply the coefficient and the power, not base. Multiply coefficient and 2 times 1 over 2 is 1. Class, I proved it here, right? 2 times 1 over 2. Can't 2 cancel 2 on top? What is remaining? 1. So I've multiplied the coefficient and the power. Step 2, write down this base or repeat the base, x. What is step 3? Say subtract 1 from the power. That's 1 over 2 minus, let me show you. 1 over 2 minus 1 over 1. 1 means 1 over 1, right? LCM is 2, because 2 and 1. LCM is 2 divided by 2 is 1. 1 times 1. Minus 2 divided by 1 is 2. 2 times 1. What is 1 minus 2? Check calculator. Minus 1 all over. So 1 over 2 minus 1 is minus 1 over 2. So by subtracting 1 from the power, we are left with minus 1 over. Class, all things being equal, you are done. No? My problem is that in your OBG exam, you will never see this in the option. They will go further. Lecture will test your knowledge of normal mathematics. Because class, if it's just differentiation, you are done here. You are differentiated, right? But normal mathematics knowledge says that you cannot leave it like this. This x raised to minus 1 over 2 can come down. The minus with this, it will now become 1. This one will still be up, but x will now come down and become 1 over 2 without the minus. When it was on top here, the minus was there, right? When it comes down, the minus this is a rule in mathematics. And we're not still done here. You will now also recall that even x raised to 1 over 2 can be written back as root. Do you agree? That x raised to 1 over 2 is the same thing as square root of x. Just like square root of x is the same thing as x raised to 1 over. Class, are we following? Now, this should be the final answer, but we're not still done. What did lecturer decide to increase the level of wickedness? By rationalizing the denominator. Rationalize the denominator. So 1 over root s. Class, when you want to rationalize the sword, take the sword below and multiply both up and down by that sword. To multiply both up and down by root x. Class, it is wrong mathematically for a sword to be in denominator. Because do not forget that a sword normally is an irrational number. Do you remember? Under types of numbers, a sword is an irrational. Now, a rational number on top divided by an irrational number can lead to the expression being undefined. Or lead to an indeterminate expression. So, class, we usually like to rationalize our sword. Make sure that the sword is not below. Because there's already something is already wrong with a sword. Normally, a sword is a rational number. It's now also a denominator. So, rationalizing the sword means both up and down by the word. Multiply both up and down by this root. 1 times root x. Root x. Now, class, root x times root x lies the rule in swords. When multiplying two swords of the same element, class, because there's x here, there's also x here. Root x times root x is simply x without the sword, without the. Just like root 2 times root 2 is 2. Root 3 times root 3 is 3. Root your school fees times root your school fees, your school. It's just a simple rule in sword, and this is the final. Not every year wants to be able to land here at this final answer. So let's go to the second question. Let's go to the second. So tomorrow by 11 a.m. we are here. By what time? By 11 we are SLT students by 12. You have SLT 9 to 12, right? So SLT students, I'll give you, join us by 12. I'll allow you to come by. But normal science students, 11. But notice that most SLT students, after that 9 to 12, they not say they are tired, they will go. They will not come for. They know that class is holding, but they will go. Even some of you are guilty, you know. You just go home, and you know class is holding somewhere. Don't do that again. Exam is closed. You have finished matric. Playtime is over. Playtime is. Moving forward, class. Second question says we should differentiate 2 cube root of x. Differentiate y equals to 2 cube root of. The cube root of x can be changed to what? X raised to power 1 over. Now you know, right? That the square root of x is x raised to power 1 over 2. The cube root of x is x raised to power 1 over 3. Class, this coefficient, this base, this power. Multiply coefficient and power. 2 times 1 over 3 is 2 over. Repeat your base. X, subtract 1 from power. 1 over 3 minus. LCM is 3. 3 divided by 3. 3 divided by 1. 3. 1 minus 3. Minus 2 over 3. So 1 over 3 minus 1 is minus 2 over what? Normally we are done here, right? But the way I'm teaching you now, you know that you're not done, right? This guy that has minus can come and the minus will disappear. It will now be 2. 2 will still be up. It's only this guy that is carrying power that will come down. 2 is still up. But 3 is down before, right? X raised to power 2 over 3 will now come down without minus. Without. When it was up, it was carrying minus, right? When it comes down, the minus disappears. Class, this will now become 2 all over 3. Don't leave it like this. Root, square root of x raised to power what? 3. Because x raised to power 2 over 3 is the same thing as square root of x raised to power 3. Oh, no, 2 over 3. Class, 2 over 3 is cube root of x raised to power 2. The numerator is the power. The denominator is the root. Class, x raised to power 2 over 3 is the same thing as cube root of x raised to power. But x raised to power 3 over 2. Class, the same thing 2 over 3 and 3 over. If it is 3 over 2, it is the square root. The one below is going to be here. The one on top is going to be power. So 2 is going to be here, then 3 will be the power. So note the difference. When it was 2 over 3, 2 will be here, 3 will be. When it is 3 over 2, 2 will be here, 3 will be. So x raised to power 2 over 3 means that 3 is the denominator to be here, 2 is the power to be here. Hello, those at the back. I'm having a class here, please. If I hear any noise again, I'll send you out. If I hear any noise again. Once I hear any noise again, I'm coming there. I'll send all of you out. This is an academic environment. If you want to talk, you go outside. Class, this remaining two, you can do them as class work. When you get home, use it to test yourself. It's the same principle. No, it's not a full sword. So you can't rationalize it. It's only a sword. The sword is only the one that occurs in square root. Yes, I was hoping someone will ask that. Now, I want to go to first principle differentiation. I believe you can do this with the knowledge I just taught you now, right? Like this third one, y equals to square root of x raised to power 3 means what? X raised to power 3 all over. Class, whatever is here, put it as denominator. Whatever is here, put it as numerator. Class, there's an invisible one here as the coefficient. There's an invisible one here as the what? So, multiply coefficient and power. 1 times 3 over 2 is 3 over 2. Repeat your. Now, subtract 1 from power. 3 over 2 minus 1 will be 1 over 2. Because 3 over 2 is 1.5. 1.5 minus 1 is 0.5. 0.5 means 1 over 2. Check it to do it by yourself. 3 over 2 minus 1. Minus 1 means 1 over 1, right? LCM is 2. 2 into 1. 1 times 3. 2 in 1, 2 times 1. 3 minus 2. 1 all over. So 3 over 2 minus 1 is 1 over. But 3 over 2, x raised to 1 over 2 is sitting as 3 root x all over. Class, this guy doesn't need to come down because it doesn't have a minus. It doesn't have a what? Minus. So don't think that every time we arrive here, you must come down. If it had a minus, then to come down, the minus will disappear. But if it doesn't have a minus, just change this x raised to 1 over 2 to root x and you're done. We're recording the class. This last one, the same thing, put an invisible one here and finish it. Oh, is they even the same questions? They are the same. Yeah, this one has now been transformed to this. Square root of x raised to power 3 is sitting as x raised to power 3 over 2. They are the same questions. Now, first principle, differentiation by first principle. Differentiation by first principle. Class, in the exam, they ask to differentiate the following function using first principle. Class, not any other option. Using first principle, differentiate the following function. Y equals, let's start with a simple question, x raised to power 2 by first principle. Class, there are two methods of differentiating by first principle. We have the formula method and we have the step-by-step methods. We have the formula method and we have the step-by-step. Let's start with the step-by-step methods. Differentiation by by what? First principle. First principle. Let's start with the first step-by-step method. Class, step 1, write down. Differentiation by first principle, step 1. Differentiation by first principle, step 1. Add the y to y and add the x to x. Differentiation by first principle, step 1. Add the y to y and add the x to x. Differentiation by first principle, step 1. Add the y to y and add the x to x. Add the y to y and add the x to x. Class, the function said y equals to x squared. Notice that I added the y to, and I added the x to x. Now, x is already carrying x squared, right? So I first forget about the square and add the x first. Then bracket everything and return back the square. Follow me, class. How do you add? It's easy to add the y to y, because y is standing alone, right? So just add the y plus y, right? But for the x, it's carrying a square. You have to be careful. Class, first clean the square and add the x first. Then bracket everything and put back the. This is how you add the x to x. So if x was carrying cube, like raised to power 3, what will you do? Clean the cube first and add the x. Bracket it, then return back the. Class, are you following? Step 1. Step 2. Make the y subject of the formula. Step 2, make the y subject of the. First of all, before you go to step 2, follow me. Follow me. Before going to step 2, expand, add the x, the y to y, and add the x to x, and expand where necessary. Finish step 1, and expand where. Because class, x plus the x squared needs expansion, needs to be expanded, needs to be what? So add to step 1 and expand where necessary. Add the y to y and add the x to x and expand where necessary. Because class, you cannot go to step 2 without expanding this first, right? And expand where. So we're going to say the y plus y, follow me, equals, how do we expand? So before we go to step 2, let us expand this. They say where necessary. This place needs expansion, right? X plus the x squared means x plus the x in 2 places. Do you agree? X plus the x squared means x plus the x, another x plus. Follow me. So you said the y plus y equals, let's expand, x times x. X times the x. X dx. X times this dx again, another x. Dx times dx. Dx, or in case I was too fast, let me take it one more time. Some of you are not good in expansion. I must consider that we have different types of students here with different level of foundation in mathematics. One more time. X times x. See, when you want to expand this kind of thing, this is a 2 by 2 expansion. This is a 2 by 2. So you take this guy will multiply both this guy and this guy. You have an answer. This guy will also multiply this guy and this. Then you are done expanding. That's the rule. So x will go here and x will also go. Then this x is done. This dx will also go here and this dx will also go. And they are both expanded. So x times x means x2. Because this x another x square. X times dx, x dx. So x is done expanding these two, right? Now this dx also x, this dx times x, x. And dx times dx means dx all. That's, we have expanded. Now, Bokla, we're not done. We now say dy plus y equals to x squared plus last. X dx plus x dx will give us x plus x, 2x dx plus dx all. And we have expanded where necessary. We have expanded where. Notice that only these two guys are added together because they are only two that look alike. I did not add this guy and this guy plus this guy because they're not in the same term. They're not in the same. But x ds and x ds look alike. So 1x ds plus another 1x ds gives us 2x. So we have 2x there. So we have added these two to have 2x. Now, can I apply step 2? Step 2 said make y subject of the. Make y what? How do we make y subject of? Sorry, not y. Make dy subject from. Make dy. Make dy subject of the. To make dy subject formula means that only dy should remain here. This y that is with dy should go to this. It should not be dy. Only dy will remain here. We'll still write out everything here again. X squared plus 2x dx plus dx all minus class. When plus y moves to this side, what does it become? Minus y. When this plus y moves to this, it becomes what? Minus y. Follow me, follow me, follow me, follow me. After that, class, we're going to substitute for y as the function. Do not forget that y is equals to x squared. Don't forget that y equals to what? X squared. Please, who has power bank here? Class, the next step, substitute for y. Remember that y equals to x squared, right? It means anywhere I see y, I can put x squared. Anywhere I see y, I can put what? Substitute for y as x as the function. Substitute for y as the what? Function. The function is x squared. So substitute for y as x squared. That's the next step. Substitute for y as what? As the function. So x squared plus 2x dx plus dx all. But instead of y, what will you now put? X squared. Because from the question, y equals to what? X squared. From the question, y equals to what? So substitute for y as the function, which is x squared. I don't want to say it in the rule that substitute for y as x squared because it's not all questions that will have y equals to x. Right? If not, I will say substitute for y as x squared because y equals to x squared means allows us to remove y and put x squared. But it's not every time we are going to be having a question that y equals to x squared. It could be another question, right? It could be y equals to x cubed. It could be y equals to 3x squared plus this. So substitute for y as the function. Class, once you have substituted for y as x squared here, what will happen is that. So what will happen is that, class, watch, can x square, there's x square here, right? X square minus x square, they cancel each other. And what are we left with? Dy equals to 2x ds. Now, there's another method of doing this first principle. In case you don't like this, I'll teach you the two methods and tell me the one you prefer. This formula method. Are we together? 2x ds plus dx all. So don't worry, in my class, I give you two options. You choose the one that you prefer. Dy equals to 2x ds plus dx all square. Why? How do we arrive here? Because at this point, x squared minus x squared gives you what? 0. They cancel out. So let's with dy equals to 2x ds plus dx all square. Class. Next step. Divide all through. Next step. You know we are doing step by step, right? Divide all through by dx. Divide all through by. Divide all through everybody in the equation by dx. Divide everybody by what? Divide all through by what? Everybody should be divided by dx. So what we have, class? Dx cancels dx here, right? Dx will kill one dx, leaving one more dx. So who has survived after the all cancelling? Dy dx on the left hand side equals to 2x. Dx has cancelled dx, right? So it's only 2x that's remaining. Plus dx. Dy dx equals to 2x plus what? Dx. Plus after dividing all through by dx, the next step is the last step. Find the limit of dy dx as dx tends to 0. Find the limit. Find the limit of dy dx as dx tends to what? This is the last step. Find the limit of dy dx as dx tends to what? 0. Find the limit of the y dx as dx tends to 0. Find the limit of the y dx as dx tends to... Class, who is the y dx? 2x plus dx, right? So this means that 2x plus dx, and anywhere we see dx, we put what? Anywhere we see dx, we put what? 0. Dx tends to 0 means that anywhere you see dx, put 0. Dx tends to 0 means replace dx with 0. So we are going to have 2x plus 0. What's 2x plus 0? 2x. Class, dx tends to 0 means replace dx with 0. Did it say replace x with 0? There is a difference between x and normal dx. It is dx that is tends to 0. So don't touch and don't do anything to this x. It is dx you replace with 0. Class, you know the funny thing? Without using first principle, can't we differentiate x squared? So why are we learning this? It's when maybe they give you a test and they say using first principle differentiate. I mean, the lecturer specified using first. But normally they just say differentiate x squared. What's the answer? Is it not 2x? So the funny thing about first principle learning is that the question they're asking you to differentiate, normally you can differentiate it, right? But because they say you should use first principle, that's where the problem starts. That's where the problem... Maybe in your manual or in a test or an assignment, they say differentiate by first principle. That's where the problem starts. Now, are you ready to look at the formula method? So you can now appreciate the two methods and decide which you prefer. Class, as long as they say differentiate by first principle, any of the methods you use is acceptable by the lecturer. It's acceptable by the what? The formula, class, in this step-by-step method, remember all the 5 steps. How many steps do I give you? 0, 5 or 4? 5 steps? 5 steps. In the step-by-step method, you must remember the 5 steps and apply them. In the formula method, you must remember just one formula and you are done. Remember just one and you are... Let's look at the formula and we'll arrive here too. Look up. So you now tell me which one you prefer. Class, I'll still use the same question so you can see that we'll arrive at the same answer. Are we together? Class, follow me. By first principle, the y dx, the formula is f of x plus dx minus f of x all over dx. F of x plus dx minus f of x all over what? Dx. Class, after applying this formula, if they see dx in your final answer, then you then apply what limits as dx tends to 0. You then apply the limit as dx tends to what? Class, it means that in this function you must get f of x plus dx and f of x. Class, the function is f of x equals to x squared, right? F of x equals to x squared. Let us go and find f of x plus dx. I've taught you how to find f of x plus dx. F of x plus dx means that anywhere you see x, add d. So you have x plus dx. Then you put the... So f of x plus dx is x but plus all square. X plus dx all square. Remember when I was telling you add dx to x, remove the square and add dx first, then add square it back. Remember? So if you want to get f of x plus, because the formula requires us to get f of x plus dx. We already have f of x. F of x is x squared. So this f of x plus dx is x plus dx all square. Let's just expand. We have expanded this guy before, right? We say x plus dx in 2 places, x plus dx all square, right? So x times x, x square. X times dx, x dx. Dx times another x. Dx times dx, dx all. So this will now give us the x square plus x dx plus x dx. 2x dx plus dx all. So class, f of x plus dx, x squared plus 2x dx plus dx all square. Somehow, even by using this formula, we are still doing some things we did in that step-by-step method, right? Because in the step-by-step method, we expanded this now. So class, I have f of x plus dx. And I have f of x. F of x is what? X I will now apply the formula. The formula says f of x plus dx minus f of x all over dx. Who is f of x plus dx? X squared plus 2x dx plus dx all minus f of x. What's f of x? X squared. Everybody divided by what? Dx. Everybody divided by what? Class, x squared cancels x squared. X minus x squared is 0, right? We're now left with 2x dx plus dx all over. Class, all over dx means divide everybody on top by dx. Class, dx cancels dx here, and dx will cancel 1 dx, leaving 1 dx. You're now left with 2x plus. Class, anytime you finish differentiating and you arrive at this, let me tell you, if you want to ask you to differentiate by first principle in the exam, and lecturer wants to be sure that you actually use first principle, he might stop his answer here. 2x plus dx. Because normal differentiation, if you differentiate x squared by normal differentiation, your final answer will not carry the x, right? If I say differentiate x squared, lecturer wants to know that you use first principle. We'll stop here at this step. If y equals to x squared and say differentiate, will you ever think of adding the x to it? No. You just say 1, invisible 1 is coefficient, right? 1 times 2, 2. Repeat your base, x, 2 minus 1, 1. 2x raised by 1 is 2. Final answer. So someone that differentiated normally will have 2x. Someone that used first principle will arrive at 2x plus. But if you want to finalize and get that 2x, you will now find the limit of this as dx tends to 0. Find the limit of this answer as dx tends to what? Find the limit of 2x plus dx as dx tends to. Class, dx tends to 0 means that anywhere we see dx, put what? So we have 2x plus 0, giving us what? 2. Our final answer is 2x. So class, after applying the formula, if your final answer still contains dx, after applying the formula, if your final answer still contains dx, you will now find the limit of your final answer as dx tends to. Find the limit of your final answer as dx tends to 0. Yes, yes, you can. Yes. In fact, I want to give you a much difficult question and you apply and differentiate. Class, we have done x plus dx before now. If you shouldn't be worried that I'm cleaning, you know how we expanded this and we have done this in the step-by-step method. F of x plus dx is add dx to x and then put back the square, right? Class, let us go to another question. I want you to differentiate f of x. If f of x equals to 3x plus 5, differentiate by first principle. Use any method you prefer. If it's the step-by-step, if it's the formula, use one of them and differentiate. Your class work. Your class work. If f of x equals to 3x plus 5, differentiate by first principle. Differentiate by what? Let me pause the video so that. Okay, class. This f of x, but you need f of x plus dx, right? F of x plus dx means you need to add dx to x. So instead of 3x plus 5, 3 into bracket x plus 5. F of x did not carry dx, but f of x plus dx will carry dx. For every x, add dx. To every x, add. What is the issue? Like, how will I add dx, right? Because that one was x squared. We did this is a different one. I'm wondering how you're going to add x, dx. So now expand this. 3 times x. 3x. 3 times dx. 3d plus 5. So f of x plus dx is 3x plus 3dx plus. F of x plus dx is what? 3x plus 3dx plus. Now, what's the formula for first principle? F of x plus dx minus f of all over class, which is easy to just memorize this one formula or memorize the 5 steps. This is easier, right? So what's f of x plus dx? 3x plus Differentiate 3x squared minus 4x plus 5 by first principle. Differentiate 3x squared minus 4x plus 5 by first principle. First find f of x plus dx. F of x plus dx means for every x, add dx to it. This will be 3 into bracket x plus dx all square plus 4 into bracket x plus dx. Okay, class. We're supposed to have minus here, right? Class, at some point, you should be used to what is x plus dx all square. So don't be wasting our time. That will be 3 into bracket. What's x plus dx all square? S squared plus 2x dx plus dx, or minus 4 into bracket x plus 5. Let's expand this bracket. 3 times x squared, 3x squared. 3 times 2x dx, 6x dx. 3 times dx all square, 3 dx, or minus 4 times x, 4x. 4 times dx, 4. Minus, this is supposed to be minus. Minus 4 times x, minus 4x. Minus 4 times plus is still minus 4 dx plus so we are going to have, this is, I'm looking for, is there anybody that can subtract or add up anybody? No. But this is f of x plus dx. This is f of x plus, nobody can subtract or add up anybody. There's nobody else that's like, is anybody that's of like them? No. Nobody's of like. This carrying dx, this carrying dx, but this one is carrying x before the dx. This is not carrying x before the class. In mathematics, it must be absolutely what precise. Very, very important. Now let's apply the formula f of x plus dx minus f of x, right? So this will be 3x squared plus 6x dx. I need a white space to do it. Let me do it below here. So in fact, let me just do it here at once. So this will now be minus f of x plus dx minus f of x, right? When you want to put this one, you put it in a bracket. Minus 3x squared minus 4x plus, put it in a bracket. Put it in a what? Now use this minus to open the bracket. You're now going to have 3x squared plus 6x dx plus 3 dx all square minus 4x minus 4 dx plus 5 minus 3x squared minus times minus plus 4x minus times plus minus 5. Make sure you use minus to open the bracket. Don't forget all over the formula said f of x plus dx minus f of x all over the class. You see that 3x squared can cancel 3 minus 3x squared will give you 0, right? Minus 4x plus 4x cancel each other. Plus 5 minus 5 cancel each. So who is surviving? 6x dx plus 3 dx all square minus 4 all over dx. Class, dx cancels dx, cancels 1 dx here, leaving 1 dx here, cancels dx here. So what is now left is 6x plus 3 dx minus 4. 6x plus 3 dx minus. Now find the limit of, because there's still dx in my answer, I'll find the limit of my final answer as dx tends to 0. Find the limit of this final answer as dx tends to 0. We're going to have 6x plus 3 into bracket. Anyway, you see the x, put what? 0 minus 4. What is 3 times 0? 0. So what I left with final answer is 6x minus. Final answer is 6x minus 4. Because I'm going to find the limit of this answer as dx tends to. As dx tends to 0 means anyway you see dx, put what? 0. Please, you don't need to rush like me. You can do it at your own pace. Everybody understands how we're applying the formula. You just apply it. And when you finish differentiating, if you still have dx in your final answer, substitute for dx as 0. That's what it means. That thing we are doing when we say limit of dx as dx tends to 0 means substitute for dx as 0. After finishing differentiating, you still have dx in your final answer. Replace dx with what? 0. And get your final answer. And get your final answer. Class, be fast so that I can go to product rule. I can go to product. Or I will do chain rule first. I will do chain rule first. I'll do what? Chain rule first. Yes, chain rule. Write down. Chain rule is used to differentiate. Is used to differentiate composite functions or function of function. Chain rule is used to differentiate composite functions. Also known as what? Function of functions. Function of functions. Class, we must understand that there are different types of functions. And not all functions will go down with your normal multiply coefficient and power, divide, subtract 1 from the new power. What makes this differentiation topic broad and large is that there are different types of functions. There's logarithmic function. If they give you logarithm, where is coefficient, where is base, where is power? How will you start it? If they give you sine, trigonometric function, they give you hyperbolic function. If they give you natural logarithm function, what do they give you? E raised to power 5x. Who is coefficient, base, and power here? You see? So there are different types of functions. So one rule does not fit all, class. That's why we have different rules of differentiation. So there are rules for different types of functions. What might differentiate this might not differentiate this one. We just finished first principle, as you can see what we did there in first principle. This one now, class, what is a composite function? Let me give you an example. Y equals to 3x plus 7 raised to power 5. Class, this is a composite function, also known as function of function. When a function is the one carrying the power, a whole function is carrying a power in a bracket. Class, this guy cannot go down by multiply coefficient and power. This guy cannot go down by normal basic differentiation. You must apply chain rule. Chain. But the good news here is if you are in the exam class, there's a short, and this shortcut does not even require calculator. So whether you have calculator or not, you will learn this shortcut today. For class, I usually like to go through the long method first, because I've tried teaching shortcut first before going to long cut. Students now lose interest in the long cut. You just be teaching yourself, and nobody will answer you, because they have now know the shortcuts. So let's start with the long. Class, in the long method, write down how to differentiate by chain rule. Let me teach you the long approach. But please, in the exam, do not use the long method. There's no time to waste. No time to. How to differentiate by chain rule. Step 1, substitute the function in the bracket with u. Substitute the function in the bracket with what? U. Substitute the function in the bracket with what? U. Substitute the function in the bracket with what? So instead of y equals to 3x plus 7 raised to power 5, it's now y equals to u raised to power. I've replaced everybody in all the function inside the bracket with u. That's step 1. Class, does it now mean that u is equals to 3x plus 7? Because if u has replaced everybody in the bracket, it means that everybody in the bracket is u now, right? It means that u now equals to 3x plus. So class, we have two functions. Follow me. The first function, the first equation we have is y equals to u raised to power 5. And the second equation we have is u equals to 3s plus 7. Last question. After the class. Yeah? No. U is 3s plus 7. But y is 3s plus 7 raised to power 5. It's y that is carrying raised to power 5. You only replace this person in the bracket, not carry the power with it now. We replace 3s plus 7 with u without the power. So, class, it's wrong to say u is still 3s plus 7 raised to power 5. It means that u is y. U is not y. So substitute only this person in the bracket with u. It's only this person inside this bracket that is u. Without the power, without the what? So u is 3s plus 7. Class, we have two equations. We have y equals to u raised to power 5. And we have u equals to 3s plus 7. Class, we're going to differentiate equation 1, also differentiate equation 2. We are going to differentiate equation 1 and also differentiate equation. Class, differentiating equation 1 is differentiating y with respect to u is dy du. dy. Differentiating y with respect to u is dy du. But equation 2, differentiating u with respect to s is du dx. Class, u to s is du, but y to u is dy du. Follow me. Y to u is dy du, but u to s is du. Class, are we together? Now, what is differentiating u raised to power 5? We are going to have, class, u raised to power 5 means that you can say it's something as 1 u raised to power 5. Do you agree? There can be an invisible 1 here. So this coefficient, this base, this power, 1 times 5. Bring down your base u, right? Subtract 1 from power, 5 minus 1. So differentiation of 1 u raised to power 5 is 5 u raised to power 4. Do you agree? Using basic differentiation now, 1 times 5, 5. Bring down your u, subtract 1 from the power, you have 4. So you have 5 u raised to power 4. So the y du is 5 u raised to power 4. But don't forget, who is u? 3x plus 7. So it will mean that if you replace u back with 3x plus 7, what do you have? 5 into bracket 3x plus 7 raised to power is dy du, is dy du. Let's find du ds. Du ds means differentiate 3x, what do you have? 3. Differentiate 7, 7 is a constant, 0, disappears. Plus, here you are aware now that when you differentiate a number with x, clean the x, take the number. So differentiate 3x, the answer is just 3. Anytime you're differentiating a number with x, clean the x, take the number. Differentiate 10x, your answer is 10. Differentiate 20x, your answer is 20. So differentiate 3x, your answer is 3. But 7 is a constant. A number without x is a constant. Differentiate a constant, you have what? 0. The differentiation of a constant causes the constant to no longer exist. So class, we have dy du and we have du dx. But class, what we are looking for in this question is dy dx. Because the question is y equals to 3x plus 7 raised to power 5. So we want to differentiate y with respect to x, dy. We're looking for dy dx. But we have dy du and we have du dx. Class, if we multiply dy du by du dx, we're going to have dy dx. So follow me. If we multiply dy du by du, we're going to have dy dx. Or what? Du cancels, du. And what's left? Dy dx. So dy du times du dx is dy dx. So class, we have proven that if we multiply dy du by du dx, we have what we're actually looking for, which is dy. So dy du is who? 5 into brackets 3x plus 7 raised to power. And who is the u dx? 3. So multiply by 3. Plus 3 cannot multiply this person in this bracket raised to power 4 because it's a complex expression. But 3 can multiply 5. 5 times 3. 15 into bracket 3x plus 7 raised to power. So therefore, the differentiation of y equals to 3x plus 7 raised to power 5 is 15 into bracket 3x plus 7 raised to power 4. Final 15 into bracket 3x plus 7 raised to power 4. I'll come again, no problem. I'll come. It's normal. It's normal if you don't understand. It's normal if you don't understand. It's the first time I'm teaching it. It's normal. Class, follow me. Let's go again. Imagine, you see how stressful this is. Imagine they will know a short way to do this and you have known it. You might not want to pay attention. I say, this is too stressful and I know how to do a short one. I'll just follow that short one. Follow me now, class. Class, you must substitute for, the question is y equals to 3x plus 7 raised to power 5. The question is y equals to 3x plus 7 raised to power. You cannot differentiate this until you simplify this expression. So replace everybody inside here with u so that y equals to u raised to power. So it means that you have let u be equal to 3x plus 7. For you to come in here, it means that u is 3x plus. It means that u is what? 3x plus. Substitute the function inside the bracket with what? U. So instead of y equals to 3x plus 7 raised to power 5, is y equals to u raised to power 5. Class, between 3x plus 7 raised to power 5 and u raised to power 5, which one is easier to differentiate? Is it not this? By removing all these big things and putting u, it's easier to differentiate u raised to power 5. Differentiate u raised to power 5 is something as 1 u raised to power 5, right? 1 times 5, 5. Bring down your u, right? Subtract 1 for power 5 minus 1. 5 u raised to power 4. You couldn't have done that with this big thing. So substitute the function in this big. That's why you deal with composite function. There's a rule for different kinds of functions. Substitute this big function with what? A small letter u. But while replacing this guy with u, you now note that, okay, so u is 3x plus 7. Remember that u is 3x plus. Because for you to remove 3x plus 7 and put u, it means that you must remember that u is 3x plus. Now, after replacing this with u, our new equation is now y equals to u raised to power. Now, differentiate y to u. You are going to have dy du. dy. Differentiating y to u will give us dy du. 5u raised to power 4. Right? But because that u is 3x plus, so that will be 5 into bracket. Instead of what is u? 5 into bracket 3x plus 7 raised to power. This is dy du. This is dy what? Now if u is 3x plus 7, let us also differentiate this expression. Differentiating u to x is du. When if y to u is dy du, u to x is du. Differentiate 3x, what do you have? 3. 7 is a constant, it disappears. Plus any number that does not contain x. To differentiate that number, the number will disappear. And differentiating 3x, you just have 3. You have what? Clean the x, take the number. Are we together? Now I have dy du and I have du dx. But what I am actually looking for, the question said y equals to 3x plus 7 raised to power 5. Find dy dx. I have dy du, I have du dx. I don't have dy dx. To get dy dx, multiply dy du and du. What will happen? Du cancels du and I'm left with what? Dy dx. So I've proven that dy du times du dx will give me my question. I'm looking for dy. So now, do we have dy du? Yes. Dy du is 5 into bracket 3x plus 7 raised to power. Do we have du dx? Du dx is 3. What is 5 times 3? 15 into bracket 3x plus 7 raised to power. Is it better now? Is it a bit better now? Yes. If it's not better, remember there's still one more escape route for you. There's a short. And don't forget your exam is OBJ. Nobody wants to see you solving, right? Just get the correct answer. There's a shortcut for you. Your exam is objective. Objective exam is at an advantage. No matter how you got, just get the final answer. Just find a way to be correct. No matter how you got there, just get the correct answer. Just find a way to be correct. Find a way to be what? Are we ready for the shortcuts? This is the second time I'm solving this. One is the same weights. There are 4 steps or 3 steps. Let's say 3 or 4. Steps, shortcut steps for chain rule. Shortcut steps for chain Write down shortcut steps. The good thing about this shortcut, you don't even need calculator for this one. Shortcut steps for chain rule. Shortcut steps for what? Chain rule. Shortcut steps for what? Chain rule. Step 1. Step 1, bring down the power. Bring down the... Who is the power? 5. Step 1, bring down the power. The power is what? 5. Shortcut steps for chain rule. Step 1, bring down the... Step 2, differentiate the function in the bracket. Step 2, differentiate the function in the bracket. Differentiate 3x plus 7, you have 3. You have what? Step 2, differentiate the function inside the... Step 3, repeat the function and the bracket. Repeat the function and the brackets. Step 3, repeat the function and the... Step 4, subtract 1 from the power. 5 minus 1, 4. I'm too fast? Step 1, bring down the power. Step 1, bring down the... Step 2, differentiate the function in the bracket. Step 2, differentiate the function in the... Step 2, differentiate the function in the what? Bracket. Are we there? I'm trying to be slow. I'm forcing myself to be... Step 3, repeat the function and the brackets. Step 3, repeat the function and the... Step 3, repeat the function and the what? Step 4, subtract 1 from the... Step 4, subtract 1 from the what? Follow me. From the uniport. Subtract 1 from the uniport. Because what are we subtracting 1 from? So we've started this topic. This is not power. Someone say from the what? From the matric. From your matric rise, subtract 1. From your matric rise, subtract... From that matric jollof rice you ate, subtract... Class, subtract 1 from the power. Subtract 1 from the... Now, class, what's 5 times 3? 15 into bracket what? 3x plus 7 raised to power what? 4. Easy peasy. I don't need to ask you which one you prefer. I think I know your answer. I think I know your... What department? MCT. Please come. Let me go and bring one past question for her. Is there anybody that paid for past question or you want to get past question? You need past question. What department? MCB. Please bring 2 past question. 1 for her. And for anybody needs past question again? You need past question. What department? Microbiology. Okay, bring 2. 1 for her. Oh, bring 3. 1 for her. You are buying 2. Okay. Oh, 2. Oh, you're in 200 level. Okay. Come. Bring for 200. It's also in the car. I'll give her. You're in 200 level. Go to the boot, Open it. You see 200 level passation. Give her 1. The one for Faculty of Science. You see Chem 250, Chem 260, Chem 235, BCH. You're doing BCH now. Bring. You see 200 level. Bring for 200. Then you see 2. Bring 2 for 100 level. Yeah, in the boot. It's also in the boot. No, it's in the back seat. It's in the back seat. It's in the back seat. It's not in the boot. Go. Open the back seat, not the boots. Bring 200 level pass question and bring 1 200 level pass question. The one for 200 level, you see Faculty of Science there. And SLT for her. Sorry, my friend, I will bring it for you. Now, class. Can we apply with that question? Y equals to 4x plus 1 raised to power 8. Ignoring the long method, let's use the short. What's the shortcut? First step 1 said what? Bring down the power. Who is the power? 8. Bring down the power 8. Step 2, what did it say? So differentiate 4x, what do you have? 4. Differentiate 1, it disappears. It's a constant, right? Step 3, what did it say? Repeat the function and the bracket, that's 4x plus. And what's the last step? Subtract 1 from the 8 minus 1. Now what's 8 times 4? Class, the rule did not say multiply this, but you should know now, common sense, right? I did not say it, I'll leave it like that. The rule did not say anything like that. You will not see this in your option now. 8 and 4 is telling you that you multi 8 times 4. 32 into bracket 4x plus 1 raised to power. Final answer. Are you enjoying the shortcuts? Sweet, right? Yes. Life is sweet, oh, right? Imagine everything is like this, right? You say? So why didn't I use the long method? Class, this short method is not as if it's in your textbook. It's we that are teaching that developed it. It's not in any textbook. It's so after I've studied and taught for so long, when I found out that it's easier way of doing this thing now. Go and check. You don't see shortcut in any of your textbooks. And lecturer come and teach shortcut before. No. It's not a normal rule. It's something that because we have been studying something for a long time, you now discover that but it's shorter way of doing this now. If I do this, like just test answer. Okay, that answer. And we tried it for different questions, it worked. So okay, you can then bring in shortcut to the students. Are we together? So normally you should suffer and do the long method. If they wanted to know shortcut, they'll do it in your textbook, but it's not in your text. Another reason why I tell students that there are some things that you cannot read in textbook. If you say I'm reading on my own, why don't you come for class? I'm reading on my own. There are some things you cannot read by yourself in textbook. Because it's not even there to start with. So how will you read it? How can you read what is not there? Class. This is chain rule for you. But another thing I want to just inform you is that if you have y equals to 3 into bracket 2x plus 5 raised to the power 8. Class, before now, I've not been putting any number before the bracket. I'll just give you something like this, right? What if there's a number before the bracket? It's still chain rule. Don't worry yourself. Don't worry your... How do you differentiate this class? Nothing should happen to this 3. Bring down this 3. Bring down this what? And apply your normal rule. What's your first rule? Bring down the power 8, right? Step 2, differentiate what's in the bracket. You have 2. Repeat the bracket, 2x plus. Subtract 1 from the power, you have 3 times 8. 24 times 2. 48 into bracket 2x plus 5 raised to power. So class, if there's a number before your bracket, don't allow it to deter you or shake you. Still, what? Maintain absolute composure and deal with the question as given to you. Are we together? Class, so if I ask you to differentiate y, class, example is for teacher, class work is for what? 3 roots 4x minus 7. Differentiate y equals to 3 root 4x minus 7. Are you aware that this is still chain rule? Differentiate y equals 3 root 4x minus 7. You brought the wrong one. Let's go again, please. The one you need has to have Chem 250, right? Chem 250, Chem 260, Chem 235. It's a 210. It's a 214. You're not doing 214. We are put it there because some people are doing it. MCB 200, CSC 280. Yes, it's there. 200 level. Are you hearing 200 level courses? So this year 1 stress is still year 2 stress. You see, they're going to buy year 2 pass question. So someone will not carry year 1 stress and put on his head in year 2 again. Pass your year 1 and leave it. There are courses waiting for you in year 2. There are courses waiting for you in year 2. Pass your year 1 and leave it. Don't carry any course from year 1 to year 2. Who is doing this class work already? Class, first things first I expect you to do is to change the square root to raised to power 1 over 2, right? Anybody's square root is that person raised to power 1 over. The square root of 4x minus 7 is 4x minus 7 raised to power 1 over 2. The square root of 4x minus 7 is 4x minus 7 raised to power what? 1 over 2. Class, once you have change that square root to raised to power 1 over 2, the question now looks a bit easier, right? What will you now do? Nothing happens to this 3. Write this 3 down, right? Now bring down the power 1 over. Differentiate the bracket. What you have? 4. Repeat the bracket. Subtract 1 from 1 over 2, you have minus 1 over. By now you should be getting used to that, right? The 1 over 2 minus 1 is minus 1 over 2. Of course, the rule did not tell you, but you should know that you should multiply and resolve, right? Multiply and resolve. Yes, 211 plus 50. 235, yes. You see it, yes. 210, yes. And 250, right? CS, and to be 200. CS to be 200. Yes, 250 is there, yes. 250, 250, everything is there. 250, look at 50. Everything is there. Look at it. Content now. 260, CS. The only one that didn't give us that is 210. Didn't give us that one. Maybe that thing is there. And my solution, see my handwriting solution for 200 level there. Now, class, please, if you've not gotten past exam question, get it. Some of you have been in this class, see year 2, come and buy past question year 2. If you do not have them in year 1, you think they will come here and buy in year 2? Have you ever seen me make an announcement to say year 2 past question? No, because it has worked for them in year 1. They are the one coming. I don't stress myself for year 2. But year 1, you have not been here before. I have to tell you the importance. But year 2, some of you have been in class, see year 2, come and pick past question up, right? Because they know. I don't stress them. They just come, I'll give them in the car. I just put it in the car. Anytime they come and buy it. So I do for year 2, I do for year 3. I have past questions. Ask your senior colleagues, I do for them. And it's not easy to see uniform pass, but I'll go and get it. Sit down, start solving. It's not easy. The solving part is stressful. Sit down, start solving different courses. You know what it means to know about 8, 10 year 2 courses and be solving them. Solutions, step by step. Different years with the solutions. Then now start printing, typing them, package them together. It's not easy, but we do it for our students so they can pass. So you need past exam questions to study. That's where you see tough questions. That's where you see tough. So if you don't have past question, get one. Your textbook example will not be enough. You need the exam question. 3 times 4, 12. 12 times 1 over 2 is 6. Into bracket 4x minus 7. Raised to power minus 1 over. Class, lecture will not stop here as the final answer in the option. You will not see this in the option. Anytime your power is carrying minus, know that something can still be. It will come down and become 6 all over 4x minus 7 raised to power what? 1 over 2 without the minus. Without the what? Which is now 6 all over square root 4x minus. Because anybody raised to power 1 over 2 can be returned back to square root. Do you agree? Anybody raised to power 1 over 2 can be returned back to square root. So you see that you might know the shortcut and not still get the answer in the exam, right? Now someone is saying come again, but they know the shortcut. I see maths exam. You know the shortcut, but this is where you probably stop, Shay. So someone that knows the shortcut will stop here, but his answer is not in the option. It now takes more teaching to still bring you here. So when I see people say, sir, why are you not coming for class? I'm reading on my own. It's okay, read on your own. Yeah, since you can't read on your. You know, I taught you shortcut, but you see that you might stop here. You now brought it here again. Hey, this math safe, eh? But thank God, after first semester, I'm not doing math again, many of you. After first semester, no more. Let me see. Everybody knows how we did the shortcut here now, Shay. Normally, change the square root to raise to power 1 over, right? Apply the shortcut, bring down the power, all those things. You know how we got here. Getting here now, you're not saying you're answering the option, you'll be frustrated. What's happening now? What happened is that this negative power has gone because this guy will come. When this guy that's carrying minus 1 over 2 comes down, the minus will no longer be. You want to see this in the option because this guy is carrying raised to power 1 over 2. I've been changed to square root. If anybody raised to power 1 over 2 is square root of that person. Anybody raised to power 1 over 2 is what? Square root of that. No, you don't rationalize this. No. Leave this like this. If you want to rationalize this, where I will go, you not like it. I will look for the conjugates. Let me not stress you. So leave it like this. Leave it like this one is okay like this. 6 all over root 4x minus 7. Now class, having understood chain rule, let us go to product rule. Product rule. For class, y equals to 3 sine cube x. Y equals to what?
3 sine.
Are you aware of this chain rule? Follow me. It's 3 what? It is same thing as 3 sine x all raised to power 3. Class, sine cube of x is sine x all raised to power 3. If someone says sine square x, it means sine x all square. It means sine x all square. So sine cube of x is sine x all cubes. Follow me. And class, in shortcut, nothing happens to this 3. Write down this 3. Now bring down the power. 3. Differentiate the bracket. Sine x changes to cos. Repeat the bracket. Sine. Subtract 1.5. 3 minus 1. Someone is writing while I'm explaining this. After you now see you don't understand. The most important part of any class is where that assimilation period. Don't joke with it. 3 times 3. 9 cos x sine x all final. This is the derivative of 3 sine cube x. I'll come again one more time. That's what you want to say. Come again. Your favorite word. Come. Class, follow me. You have a question? I'm already coming again. So whatever you want to ask, is it not in this question? You're not asking my name. My name is Success. What do you want to ask me? Is it not this question we're teaching? We subtracted 1 now. 3 minus 1. That's why we have 2 now. Yes, I did that. Now, follow me. Please be fast. I have jam class by 4. If you have someone, anybody writing jam, you have your junior brother, your junior sister, or you're taking jam again to change your course or whatever. You just feel like taking jam. Put it together. Direct your colleagues or your friends to our class. You have a friend that has not gotten admission. You want to get a very high score in jam. My students will blast jam. They say, well, I'm taking that jam class very serious. Direct them to us, success jam class. I have a jam class by 4 here today. Direct them to us. We'll break it down for them. Chemistry, physics, or maths, biology. Direct them to us. We have a jam, private jam class for my students. I break down jam for them. It holds here. I do it Monday, Tuesday. See me after the class for that. If you are interested in the jam or you have someone that is writing jam, it may not be you, but you might know someone. You understand? It might also be you too. Anyone. It may be you, it may be I, it may be someone by your side. Class, let's go again. 3 sine cube x. You must first change sine cube x to sine x raised to power 3. Sine cube x is written as sine x all raised to power. You must first understand that in mathematics, sine cube of x is written as sine x all raised to power. We'll now start differentiating using our shortcuts. Class, nothing happens to this 3. We brought it down 3, right? Now, what is the first step in chain rule shortcut? Bring down the power. So this first 3 is the 3 that was in the question. This second 3 is the following the rule. Bring down the. Step 2 says differentiate what is in the bracket. Class, anytime you differentiate sine x, note it changes to cos x, 0. Next week, if you are serious enough to attend my next week Wednesday class, which I feel 3:30, I'll teach you trigonometric differentiation. How to change sine x to cos x, how cos x change to minus sine x, how tan x change to sec square x, cos x change to minus cosec square x. I'll break down all the rules. Log, natural logarithm, hyperbolic. So class, sine x changes to cos. Now repeat the bracket. Sine, subtract 1.5, 3 minus 1. So 3 times 3, 9 cos x, sine x all, which can be written as 9 cos x sine square x. Because sine x all square is written as sine square. Sine x all square is written as sine square